All right, so what we're going to look at today is section 8.2, and we are going to add a constant to the end of what we looked at yesterday. Yesterday, we just graphed what happens when we have f of x equals a times x squared. Now we're going to add this plus c onto the end, which will always be a constant. It doesn't have a variable. So an example would be something like y equals 2x squared plus 3, or y equals negative 4x squared minus 1. Each of these now has a c value at the end. We're going to look at what happens when we have that. So, you just watched the video where you saw the sliders and what happens when we move the values of a and c up and down. And so hopefully you had a chance to answer those questions. Let's go ahead and summarize what hopefully you found on here. Now, when we looked at when a became bigger than 1, you should have noticed that the effect on the graph was that it became narrower than the parent function. So let's go ahead and write that down. So the graph gets more narrow, and then here's a picture. We've got our parent function first, and then when we change it, the sides pull closer together, and it becomes more narrow. So when we look at when a is less than a, but less than 1, so we're talking about basically fractions that are between 0 and 1 or decimals, the effect on the graph that you should have noticed is that the graph gets wider. And so this is what we see here. You're going to have to put this on pause to be able to get these copied down in your notes. When a is negative, the graph flips over, and what we call that is a reflection over the x-axis. The graph is flipping over the x-axis. Lastly, we looked at when we change c. When c is greater than 0, the graph moved up, but c does not change the shape of the graph. And when c is less than 0, the graph moved down, but the shape doesn't change. Basically, it's moving the vertex. So when we sketch out what happens, again, notice C is changing the location of the vertex. A does not change the vertex at all. The vertex stays at 0, 0 until we change the value of C. So looking at these functions, what we want to do is be able to think about what is happening and be able to tell how the graph is going to change without actually having to look at the graph. So there's a couple of things that I notice if we look at this first one. The first thing I notice is that there is a negative in front of the A. So A is negative. I also notice that A is 3, so that means that A is greater than 1. And then here, C is equal to negative 1. So those are the three parts that we need to notice. So the negative is going to flip the graph over. It's going to be a reflection over the x-axis. The value of A is going to make the graph more narrow, and the value of C is going to move the graph down 1 unit. So this is how we would write that. So we could say that there's a reflection over the x-axis, the graph gets narrower, and that it moves down 1 unit. So we can look at number 2 in the same way. Go ahead and pause for just a second and see if you can figure out what things are important here. So what I see is my value of A is 1/2. So that means that A is between 0 and 1. I don't have a negative, so I don't need to worry about that. And then here I see that C is equal to positive 4, which tells me that it's going to move up. So the graph will be wider than what the parent function is, and it will move up 4 units. So let's graph a couple of these. Notice again that there's 2 parts to the question. We want to first graph g of x is equal to x squared minus 2. Then we want to compare it to the graph of f of x equals x squared. So let's go ahead and set up our table with the same values that we talked about yesterday. So now remember, once we choose our x values, those are our ins, so we have to plug it in here for x to see what we get out. So I'm going to do negative 2 squared minus 2. That gives me 4 minus 2, which is 2. Then I do negative 1 squared minus 2. That's 1 minus 2, so I get negative 1. 0 squared minus 2. That's 0 minus 2, so I get negative 2. 1 squared minus 2 is also negative 1, and 2 squared minus 2 is also 2. So let's go ahead and sketch those points on our graph. So I have negative 2, positive 2, negative 1, negative 1, 0, negative 2, 1, negative 1, and 2, positive 2. So you can see that it has moved down. Now make sure again that your graph is a U, not a V, and make sure your arrows go all the way out to the edges of your graph. So now we want to compare that to the parent function, and we looked at what the parent function table looks like yesterday. Remember, it's just take all the x's and square them. So negative 2 squared is 4, negative 1 squared is 1, 0, 1, and 4. So I'm going to sketch that in red so we can see what that looks like. And really, now that you know what all of the variables A and C are going to do, you could answer this question without seeing the graph. So even though it looks like the purple graph got wider, it didn't. We can just see more of it. And so because A is equal to 1, that means the shape of it didn't change at all. All it did was move down 2 units. So we can say g of x moved down 2 units from f of x. And that is it. So that's one where we only changed the value of c. Let's look at one more. I have g of x is equal to 4x squared plus 1. So just like on the other one, I'm going to start by filling out my table. So to figure out each of these values, we're going to plug in for x. So I have 4 times negative 2 squared plus 1. Remember, we have to do exponents before we can multiply. So negative 2 squared is 4. 4 times 4 is 16, and then 16 plus 1 is 17. That's how I'm going to get all of these values. So I'm going to go ahead and fill in the rest. So you can see I ended up with some big numbers for my y values, those 17s. Those aren't going to fit on my graph. That's okay. But that does give us an idea of how steep the sides are going to be. So let's go ahead and plot those points. Negative 2, 17, that won't fit, so I won't worry about it. Negative 1, 5 will be here. 0, 1 is my vertex. And here is 1, 5. Now the 17s, they won't fit, but that does tell me that my sides are going to come down really steep before I get to the bottom. So it'll look like this. Now these ones that are super narrow, it's kind of hard to make them not look like a V, but just do your best. And so you can use that same table from before for your parent function to graph it and compare, or you can just use what we know about what the parts of the function are going to do. So we can see that it got narrower and that it moved up 1 unit. So that's what you're going to be looking at today, is when we change the value of C, what happens to the graph. Make sure that if you have to graph, that you use graph paper.